My name is Nathan McMinn. I'm a technical consultant with Alfresco's professional services practice, and I'm here to word about digital signatures. So the definition is sometimes a little bit muddy. People talk about digital signatures versus electronic signatures. A digital signature specifically is a mathematical scheme for demonstrating the authenticity of a message or a document, and that came straight from Wikipedia. Had to put a Wikipedia plug-in after their founder did our keynote in Barcelona. There are really three criteria for defining a valid digital signature. So the first is authenticity. So we need some mechanism to guarantee that the person who's applied a signature to a document is who they say they are. As part of that, we also want to convey intent, that this document was signed for a reason, that it wasn't just something accidental. We also need non-repudiation. So non-repudiation basically means that it's impossible for a signer to make concurrent claims that their key is secure and that they did not sign a document. So we want to be able to prove that if they're going to claim their key has not been compromised, that they did indeed do this signature. And to do that, we need some hard-to-forge signing artifacts. That's always been like the big weakness of a wet ink signature on a document, right? Is that anybody could really forge that with enough practice, and sometimes it doesn't even really take all that much. These things can be traced. The last criteria for a digital signature is integrity. And what we mean by integrity is verification that the signed content, document, message, what have you, has not been altered since it was signed. So we can accomplish all of three of those with some basic digital signatures. So how do these things work and how do we achieve these goals? Well, digital signatures start with a hash of the document. So, a hash is a unique representation of the content. That's a fixed length string, right? So we take that hash, we sign it with the user's private key. For some file formats, we can take that resulting encrypted hash and actually embed that into a document to carry it along with the document as it moves from place to place. And then when we want to validate that signature, what we actually do is we take that encrypted hash, we decrypt it with the user's public key. Now, if it decrypts properly, we know at this point, we can guarantee that it was indeed signed with the corresponding private key. We take the resulting hash from the decryption operation and we compare it with a newly generated hash of the exact same document. And if those two hashes match, we can guarantee that the content hasn't been altered since it was signed. Just a quick word on the differences between digital and electronic signatures. A lot of times, especially in product brochures, marketing information, you'll see these two terms used interchangeably. And it's really important to put the distinction in place that these are not the same thing. A digital signature requires a cryptographic signature. So it has to be something that is actually cryptographically signed, that has those three characteristics that we mentioned earlier. Electronic signatures are much simpler. That really is just, it can be as simple as a signature image. So basically it looks like and acts like a wet ink signature on a paper document. Electronic signatures typically don't carry the same legal weight as digital signatures because they are simply so easy to forge. When we start talking about signing content, it's really important to note that anything can be signed, but some file formats have features that make signatures easier to manage, easier to deal with. In particular, the PDF document type. PDFs have kind of become the gold standard for legal documents, contracts, anything that flows through your organization that you have to be able to prove it has not been changed, is valid. They render properly on a wide range of devices. They have great fidelity from screen to print. And because of that, they've really kind of taken over in terms of the document standard of choice for these sorts of docs that we might want to sign. One of the things that makes PDFs uniquely suited for this role is the way that the documents are actually split up. So a PDF document really is a kind of a collection of dictionaries, and there's separate areas in the document for the actual content of that document and things that might live in the header, such as the author information, or in our case, the signatures. So this allows us to do some neat things with PDFs, like actually create a signature of the content embedded in the document and without actually altering the document content itself. This is also how PDFs enable some of their encryption features, where you can actually take the document and encrypt the content but leave the metadata exposed so that Alfresco's metadata extractors can pull it out and actually make those things searchable. But the important feature to note for the purpose of this talk is that we can do multiple signatures embedded in a PDF document, and adding subsequent signatures does not invalidate any of the previous signatures because it doesn't actually alter the content. So we can actually sign anything. I mean, any message, document, piece of content you have, we can generate a signature for that by the method we discussed earlier. Generate a hash, encrypt the hash with the private key, take that encrypted hash and the document and provide those to somebody, and they can in turn now, with your public key, validate that that signature was generated by you. Now that does require some manual intervention typically. It's not something that, that is built into most file formats. So, you know, Microsoft Word has some of the same features of PDFs, but they're not quite as easily accessible from Java. So the CounterSign doesn't support that yet, but we can still sign those documents as if they were any other type of content. Some of you might be familiar with the Alfresco PDF Toolkit. Anybody? Okay. The PDF Toolkit has some rudimentary digital signature features already included. These features are really geared towards system signatures. So you might configure a custom action, for example, you know, a rule on a folder that executes an action that would apply a signature to a document. This is useful if you just want to do a system signature, so prove that the document was received by your Alfresco repository and that it has not been modified since it was received. However, for user signatures, the interface, as we'll see in a second, is pretty bad. So what started out as a series of enhancements that were requested during last year's DevCon, I started a new branch of the PDF Toolkit to just add digital signature enhancements. As often happens, that that little sub-project, that branch, kind of took on a life of its own. And at some point a few months ago, it kind of started to make sense to go ahead and fork this off into a separate project. The scope of it has gone way beyond just PDF documents into some PKI and some other things that are simply, I consider them out of scope for the PDF Toolkit. So at this point, we've really forked the project. The Alfresco PDF Toolkit version 1.2, which is going to be the first release that's Alfresco 4.2 compatible, should be out by the end of the year. And then CounterSign for Alfresco version 1.0, which targets Alfresco 4.1 Community or Enterprise, was just released a couple weeks ago. And then, of course, when we move on to 1.1 of CounterSign, that's when we're going to add Alfresco 4.2 support. So if you were to go in today and use the PDF Toolkit to try to sign a doc, you'd get a UI that looks a lot like this. It's not something a user's going to do, right? Are you really going to ask a user to find their private key file in the repository and remember their key password and their store password? Ask them to put in things like the signature location, XY coordinates. You know, I really don't think that that's, no, nobody's going to do that. So after looking at the way it was done and really just how unfriendly it was for an end user to do this, I set out some broad design goals for CounterSign as a project. The first one, and this is, I should have put this in like big red font in bold, is that it has to be simple for non-technical users. The target audience for a CounterSign user is a business user. This is designed for somebody who does not know what a key store or a private key is and doesn't want to know. It should also be self-service. So I don't want to have a user go out and generate a key and upload it to Alfresco anywhere. Likewise, I don't want them to have to email an administrator to have one of these keys generated for them. That's certainly possible if you wanted to lock this down and put some more controls around it, but by default, our goal here is that this is going to be a self-service product. It has to be simple to administer, so I've tried to keep the number of configuration options really to an absolute minimum. Just what the administrator needs to set this up. All the properties, as we'll see in the demo portion, are actually overridable in the global properties file, so you don't have to do anything funny to get this working. You add a half dozen settings to global properties and you can get going. Number 4 is it has to be self-contained. So a lot of organizations already have some form of PKI, so public key infrastructure, but a lot of companies don't. And to get around that, I've kind of built a mini, sort of a lightweight PKI within the Alfresco repository to handle managing these key stores and keys for the users, while leaving open the option of external PKI integration. So essentially, there's a Java interface that defines the expectation for the key management component. Right now, that key management component is implemented as a series of calls to node service and such, Alfresco internals, to store those keys. There's nothing stopping somebody from re-implementing that interface in a way that connects to some sort of external PKI so that they could integrate with whatever they happen to have on hand. And the last one is regulatory and standards compliance. Do we have anybody here that's in a regulated environment? Okay, is that FDA or? Oh, yeah, okay. Yeah, you've got a whole alphabet soup of things you have to deal with. So one of the goals of this project is, where possible, I'd like to get to a point where this can be used to build solutions that can become part of your regulatory compliance framework. Just a quick note about regulations. So things like FDA CFR 21 Part 11 are really big in the medical device industry. Most of these regulations are actually a mix of technologies and processes. So when a vendor tells you that they have a compliant solution, if you read between the lines, what they're really telling you is they have the tools for you to build one. Generally speaking, there's a lot of process stuff that goes along with becoming compliant. So you have to be able to prove that you use, say for example, in an FDA regulated environment, that you have standard operating procedures and such, and that they're under change control, and digital signatures may form a part of that, but they're not a solution unto themselves. So that's kind of the goals, broad goals of the project. We also have some design goals for the APIs that we're going to expose as a part of CounterSign. So there are really 4 ways to interact with this particular extension. There's a Java Service API. Right now it's very sparse, but I'm adding things to that with each release. There's a JavaScript API, and this API exposes a new root scope JavaScript object called CounterSign that you can use to access some of the underlying functionality. There's the aforementioned signature provider interface for external PKI integration. And lastly, there's a set of custom actions that we can use for things like applying signatures. We can also use that for creating signature form fields and doing some other signature-related items. One last word on standards. The current CounterSign release is not going to be able to achieve some of those regulatory goals. So there's 2 big standards in Europe that are kind of driving what it means to create next-generation digital signatures. These have all evolved from a standard called CMS. So those are CADES, PAIDS, and then there's another one called XADES. And those make some pretty clear definitions about what we have to do to achieve a valid, compliant digital signature. Unfortunately, there's an encryption library in Alfresco that is, it's really frustrating. It's 0.1 version older than what I need to get to the compliance level I have to get to. So, I've opened up a ticket to try to get that library upgraded as next releases of Alfresco come out. A lot of the functionality here depends on iText. So really that encryption library dependency is driven as a transitive dependency off of the iText product. So with that, we're going to move on to our quick demo. When we start to look at CounterSign, the project itself is just delivered as 2 AMP files. So there's one for the repository, and then there's one for the share tier. The repository tier extension carries things like the custom actions, the content models, all of the API components. And then the share UI components covers, of course, all the user-facing bits and pieces of this. So the share form configurations, the workflows, and all of that. If you're planning on only using the custom actions from your own code, so say you have a custom workflow app or a custom application of some type in your organization, and you just want to leverage the signature APIs and the signature actions, you can absolutely just forego the share component and just install the repo tier. There's not really any hard dependency between the 2. So once we get this installed, we have a few things that we have to set up. The first is the valid duration for the signature key store. So when we generate a key, the key has a certain time that it's valid for. By default, we set that up for 1 year. We also have to provide an alias. So an alias is used within a key store to identify a specific key. So by default, we just set this to CounterSign. This next setting, Enable Trusted Certs, was a late addition. When we sign with a key, right, that key may have a trust chain that goes back to some type of a certificate authority. So it's really common, or really similar to what you might do when you get an SSL certificate, right? You'd go to VeriSign or Thought or one of these companies. You'd get an SSL certificate from them. They do some legwork to verify your corporate identity to make sure that they're issuing a certificate to you that carries your corporate credentials, and to make sure that the person who they're issuing the certificate to really does represent that organization. The same can be done for signing certificates. So if you can get a root trusted cert, you can use that with CounterSign, and then we'll generate subordinate keys and establish that trust chain automatically. If you don't want to go through the cost of obtaining one through a CA, you can always generate one yourself, or if you're running Active Directory, I think you can actually just pull one out of there, and it'll be trusted, and we can use that to generate these specific keys for the users to do their signatures. So we also have to provide, of course, if we're going to do that, a path. We're expecting there a PKCS12 key store, which is a fairly standard format for managing these keys. If we're going to use everything from here on down, pretty much is only relevant if you've enabled trusted certs. So if you're going to provide a key store, we have to know the passwords. We can crack that open and access its keys. Same thing with the certificate alias and the key alias. So we have to know which certs and keys we're going to grab from that key store. And then lastly, there's a couple of settings here that you probably won't need to change, but things like which hash algorithm are we going to use if we're signing non-PDF content, what signature algorithm, what JCE provider we're going to use. Bouncy Castle is actually the encryption library that Alfresco ships with, and it's got that. This is the one that has that dependency that I mentioned earlier. So by default, we use the Bouncy Castle provider. And lastly, as we'll see, there's a couple of UI components that have dependencies on some cloud services. So specifically, there's some map integration here. So we use the leaflet library for that. And if you want to enable those components, you'll have to get an API key for leaflet so that we can actually integrate with that tool. And then we can also configure here what date format we're going to use. This is going to be replaced shortly with just something. We're going to pull the locale for the user instead and just use the locale appropriate format. And then some components on the password strength. When we generate a key store for a user, as we'll see when we start the live demo part, we actually require that user to create their own key store password. So the first time somebody goes in to sign a document, they get a little dialog there that requires them to enter and confirm a password that will be used to protect their key store. These numbers set the minimum required strength values for those passwords. It's really on a scale of 1 to 100, and the exact regexes involved in figuring that out are out of the scope of this talk, but the code's there if you want to take a look. So we really ran them 3 ways: a good score and a strong score. If it's good score or higher, then it's good enough to be used for the key store password. The key store passwords themselves, just as a quick note, those are not persisted anywhere. So one of the things we come across in some of these regulations is that user impersonation should not be possible. So in order to be in a compliant environment for some of these regulations, you have to be able to say, it is not possible for even the admin of a system to impersonate a user and apply a signature on their behalf. So when we ask the user for a password and we generate a key store for them, that password is only used to generate the key store. It is not persisted anywhere in the database or the repository. So if the user forgets it, they actually have to go in and generate new keys. It's just important to let people know, if they're going to be using this, that they need to remember that password, maybe write it on the bottom of their keyboard. So with that, we'll get on to the demonstration part. So this is just an Alfresco 4.1.6 enterprise instance. And I'm going to sign in initially as an admin user. And we're going to start by looking at this CounterSign site and its document library. I've put a couple of simple pieces of content in here. Actually, hold on a sec. Let me make this a little easier to read. There we go. So we've got a couple of different PDF docs and then a Word document that we're going to use to demonstrate the external signatures. To start, I want to take a look at just this simple contract document here. And we'll drop into the document details view. This should be familiar to anybody who's ever looked at Share. At the bottom here, we have a new action called Sign Document. So if we click on this, we're going to get another preview of the doc. It's a little bit different. Notice it doesn't have all the controls here for scrolling and zooming and all the stuff that makes up the document previews. And then on the left, we have our little signature panel. And this is where we're going to put in all the information that we need to actually sign a doc. A lot of these some of these fields were driven off the PDF spec. So PDF asks you for the location of the signature, so where you were when you signed, something like my office, my home, my car, the moon. They might ask for the reason for the signature, something like approved for release, or why you're actually doing the signing. There's our two signature fields, so the password and the confirm password. And then we have a few options about exactly what this signature is going to look like. So thinking back to what we said about electronic signatures versus digital signatures, CounterSign is always going to apply a digital signature. It may or may not apply an electronic signature, depending on how you've configured these options. If you uncheck Apply Visible Signature, it's simply going to create a cryptographic signature on that document. It's not going to try to create a wet ink signature or a graphic and embed that anywhere in the content. With Apply Visible Signature checked, we have a few options as to where we want to put this. So we could put this in a signature field. PDF documents support the concept of forms, right? So everybody's worked with PDF forms at one point in time or another. In addition to the usual form field types like dates and text boxes and all that, PDFs actually support a field type called signature, where if you were using Adobe Pro or whatever and you design a contract and you want to email it to somebody and say, sign it here, that's how Adobe defines where actually you expect somebody to sign. We can also draw a location, so we can tell it within this previewer exactly where we want the signature to be applied. So if you're dealing with a document that doesn't have any fields defined already, you can apply that signature pretty much anywhere on the document you want. And lastly, you can do this in a predefined location, which is the default. So our predefined locations, these are just basic, right? Where you would actually might want to stick the signature. For the purpose of this demo, I'm just going to put this up in the top left page, top left corner, and I want to apply this on page 1. I'm going to use a signature image here. So the difference between a visible signature and a signature image. Visible signatures, if that's not checked, there will be no visible indication on the document that it has been signed. If we uncheck use signature image, we get a system-generated block that gives us some basic information. The person who signed, the reason, the location, the time and date, all that sort of stuff. But it's actually a system-generated image, not the user's wet ink replica. So in this case, I'm going to apply a wet ink signature. And I'm just going to do my little John Hancock there. I'm going to put in my location. What city are we in again? Boston. The reason, demo. I'm going to put in a signature password here. Again, you have to do your little password strength checking, so this meets the criteria that we set in that little config file. It's not a great password. It's a good password. And I'm going to click Sign Document. When we do this now, we drop back to our document preview, and we can see that signature has actually been applied up here in the upper left where we specified that. The signature images do have a little bit of a pixelation problem. There's a new version of the signature control that just came out that does some really cool smoothing. So that's in the latest branch, but I didn't get that folded in time for the demo. So we were talking about signing a doc, right? I'm going to sign out as this user, and I'm going to sign back in as myself. And we're going to go right back to the same site, back to the document library. And now, because that document's been signed, we have a little indicator here that shows us that this document's been signed with CounterSign. So it's a very easy way within a document view to see, well, yeah, okay, somebody has actually signed this. I want to click back into that same document, and I'm going to go down to Sign Document again. And this time, I'm actually going to do it a little bit differently. I'm going to put in the location is still Boston. The reason is still demo. I'm signed in as a new user now. This user has also never signed before. So just like we did last time, they're going to be required to create a signature key store. Whoops. This time I'm not going to I'm going to apply a I'm going to apply a visible signature, but I'm not going to use a signature image. And I'm actually going to select a drawn location. So for this one, I want to put this in this little space that we've left on this contract for the first approver. So I'm actually just going to draw out where I would like that to appear. Click Sign Document, and there we have that, an example of that system-generated block, which is going to show us that this document was signed. We don't actually have a wet ink style signature for the user, so we're just going to display this kind of placeholder metadata block instead. One thing that you probably noticed, signature not verified. That's been a bugger of an issue, frankly. When we do renditions in Alfresco, we use PDF to SWF to create an SWF version of our PDF document, which we then feed into the web previewer, right? Unfortunately, PDF to SWF has absolutely no idea how to validate a signature. So every time PDF to SWF renders something, it's always going to render it with signature not valid. But if we were to actually go and download this doc, and we pop this open in Adobe Reader, we get a different story. So when we actually go to view this in the reader, we'll see that this document has valid signatures. So sign and all signatures are valid. If we scroll down a little bit, we get the nice big green check telling us, yes, indeed, this is a valid signed document. If we want to see some more information about this, we can click on the signature and view the properties. And the signature properties will tell us just a few basic things about it. So we can verify again, it hasn't been modified since the signature was applied. So there's our document integrity part. The signature was validated. So we know that this is actually a valid signature signed by the person who said they signed it. If we take a look at the signer's certificate, we get a little bit more information about this. So we can actually see what the trust chain looks like. So remember I talked earlier about establishing a single root certificate that's actually used to generate these subordinate certificates that the users use to sign. I created one myself called CounterSign.it, and that's been serving as my root CA. So the process would be the same if you obtained your certificate from your internal infrastructure team or from some other canonical authority like VeriSign or Thought or whoever. So we can actually look and see that, yes, indeed, the certificate is subordinate to the root cert. We can take a look at the certificate details, which just gives us some basic info about the size and the level of encryption that's involved. This is another part that's coming with the compliance bit. So we're not providing information on revocation status. As soon as we can get that library updated, we're going to implement two things that will give us the ability to do this. The first is CRLs, certificate revocation lists, where we basically tell Adobe where it can go to find a list of revoked certificates. The second is OCSP, which is Online Certificate Status Protocol, which works a lot like CRLs, but instead we actually are able to query a web service as to the status of a particular certificate. So once we have our libraries updated and I can get the latest version of iText in here, we'll be able to include those two things and actually revoke certificates if those keys are compromised. It shows us our trust. So with this certificate that we're looking at is actually trusted to sign documents or data and to certify, but we haven't given it permission by default. So I think this is the default behavior for Adobe to execute dynamic content or execute high privilege JavaScript. Those things can pose local security risks if you allow content to do those things. Might not be bad if you actually trust the person that gave you the content, but still something that makes me kind of nervous. So going back to the demo, we've got a couple other features here that are worth mentioning. So we talked a minute ago about if you open it through anything that is able to validate a signature, it will show signature valid. This is all to the PDF spec. So any tool that's capable of validation should validate. Yeah, preview actually is not really capable of doing it right. We can open it in preview, and what we're going to see here is the same, signature not verified. Now, I think there's some additional configuration you can go through on the Mac side to add the root cert to your local keychain, and then, or at least add a trust relationship for it, so that these will verify. But for the time being, no. So preview's kind of weak in that area, actually. No, that's a very good question. The password that you enter when you do your signing is totally unrelated to your login password. Because one of the things we have to achieve some of the regulatory goals is that password something that can't be impersonated, right? So if we use the user's login password, conceivably the administrator would be able to recover that and potentially impersonate a user to do a signature. So when they enter that password twice, they're actually creating a brand new, only used for signing password. It's a separate pass just for that.
Okay, so later on, like some reason, like legal reason, they have to claim that they have signed, they have to remove that password.
No, because the user's public key is actually stored outside that key store. So we would still be able to validate the signature even if the user forgets the password. Now, if they want to apply any additional signatures, they would have to clear that key out, basically regenerate their key store, and start from scratch. But the existing public key, or the public certificate, rather, public key remains in place, so they could still validate it. I've got that in the demo. I'll show you. That's part of the part of the PKI component of this. So we talked a little bit about PDF form fields. You could create those through something like Adobe Acrobat Pro if you wanted to. We provide another way to do that. So if we drop into this, this multi-page contract doc here, one of the other actions that we have for PDF documents only is actually one called Add Signature Field. And it does exactly what you think it does. So we're going to click on Add Signature Field. We get the exact same view we had a moment ago. I'm actually just going to go ahead and just put it up on the document header. I'm going to call this Approver. Click Add Field. And we've now created a signature field for this. If we were to view this document through anything other than preview, we wouldn't actually see the box. This is another glitch in PDF to SWF. I'm not sure if it's intentional or not, but it always shows the box. So if we go into Sign Document on this one now, and we select Signature Field, there's our Approver field in the doc. So the use case here is really that you could have the content author, the person who's put this contract up, go ahead and define where they want somebody to sign it. I'm going to put in my password. I'm going to go ahead and apply my little wet ink signature there and click Sign Document. And now we've got our signature in the area that we've defined with that little, it's a very, very simple little PDF editor that lets us insert just signature fields wherever we happen to want them. Note now that we've added a signature field though, and we've signed this document, that the Add Signature Fields action is gone. Once a document is signed, you can't add any additional fields to it because that modifies the content area, which would thus invalidate any previously applied signatures. One other feature that we've got with this application is some pretty simple, but I think useful workflow. So I want to take a look at this simple contract doc that we've already gotten signed twice, right? And I'm going to go in and I'm going to start a workflow on this. The workflow that I'm going to start is the CounterSign Send for Signature workflow. Give it a couple of very simple parameters. I'm going to pick a signer. Who am I logged in as right now? Me, okay. I'm going to send this to the administrator for signature. And go ahead and kick off this workflow. When I log back in as the administrator, I've got my sign please action there telling me I've got to go ahead and sign this doc. I'm just going to click through. I'm going to say I want to sign it. I'm going to go ahead and just do a drawn location for this one. We're going to put it down in the second approver field. Enter my key password again. And click Sign Doc. Now once it's been signed, I'm taken back to the workflow page. I can go ahead and mark this as signed. I'm going to log out as administrator, log back in as myself. I can see that there's a confirmation for this, so we can say, yes, indeed, this has been signed. I can actually go in and view the document details here if I want to. Say, has it really been? Yes, they signed it. So I'm going to go ahead and accept the signature, which actually ends the workflow. Now, what that does for us is we've collected a bunch of information at this point, right? We've got 3 signatures applied to this document. We've got a simple workflow that walked somebody through sending it to somebody else to sign it and then getting a confirmation back. But all that's not terribly useful if we can't actually see it. So we're going to drop into this simple contract doc page again. And once a document's been signed, we have this View Signatures action at the bottom. We can actually use this to view all of the existing signatures that have been applied to a doc. So if we click on View Signatures, it's going to show us, looks a lot like the Share Preview page with a few twists. We have the applied signatures. So for each signature that we applied, it's going to show us who did it, their user ID, the reason, the location, and the date. It also does some pretty simple map integration. So when somebody does a signature, if they've enabled it in the browser, and if geolocation data is available, we actually add the, I think it's the geolocation aspect to the signature, and we stick the latitude and longitude to where they were in there so that we can actually map that out and show where somebody was when they actually signed this doc. And then the last component is a document timeline. This is going to show us, for this individual document, what are the relevant signature-related events. So initially, we see this document was created. We can see that it was signed once, the first time I signed it during the demo, so it was signed by the administrator. It was also signed by me. There's a little glitch in the signature workflow timing. If they're close to the same time, they're flipping in order. We can see that the signature workflow was started, the document was signed. Oh, sorry, that's actually a different signature. And then lastly, that signature was actually confirmed. So we're presenting just a couple of views of the signature information here. You know, who did it, just as a list, where they were when they did it, and then a timeline that shows us what exactly has been happening with this document over the course of its lifespan. One of the other features for CounterSign is that we don't just handle PDF forms that are created within the tool itself. So if you've created a form, so this is a same version of our little contract doc. The only difference is that this one already has a form field that was put in by Acrobat Pro. We can go in and we can actually extract those pre-existing form fields. So if your legal department, for example, has some contract forms you're using already, you know, they already have the form fields defined and you want to go ahead and make use of those, you can. We'll just go into Manage Aspects. CounterSign adds a new aspect called PDF Document with Signature Fields. When we add this aspect to a doc, what we're actually doing is reaching into that document, getting a list of all the form fields that are a part of it, pulling out the signature fields and adding those to the document metadata so that CounterSign now knows this document has fields applied. We're going to go in and sign it. And if we pick signature field, we can see there's a list of the 3 fields that I actually had defined in this doc. So I'm going to apply this signature in the first field, and just for kicks, I'll turn off the signature image. So there's our signature applied. If we go back to sign this document again, CounterSign's smart enough to know that that field has already been occupied. So subsequent signatures can only be applied or only be added to unoccupied fields. So that's kind of the overview of what we get in terms of PDF functionality for CounterSign. It's a pretty rich set of features for the end users to go in and do these signatures. Most of these things are pretty workflow friendly. There's a lot of enhancements coming. Most of the new stuff that's coming in CounterSign feature-wise is centered around workflow. And I'll get into that when we wrap this up in terms of what our feature list is going to look like. That still leaves the question of what do we do with non-PDF types. So I want to take a look at this simple Word contract here. Once CounterSign's installed, by default, it's going to show you the signed document link for everything. These are just evaluators and shares, so if you want to constrain these to some specific document types, you can certainly do so. By default, we show it for everything. So I'm going to click on Signed Document here. Notice that we don't have all those extra fields for the position, right? We can't apply a graphic signature to any arbitrary binary content type. We really have to be able to just store that externally. So the signature field is a lot simpler. It's just the location, the reason, and the password. And of course, this is the same one that they've set up for signing PDFs. This is all the same key stores. So I'm going to click Sign Document for this one. If we go back to the document library, we still get the signed indicator, showing that it's been signed by CounterSign. All that means in this case is that the document has the signed aspect, and it's going to have some pointers to where to find the external signature. So if I take a look at this doc in the details view, I have a new action now, Validate Signatures. Right now, Validate Signatures is only available for non-PDF types, because PDF types, of course, can be validated with any number of existing tools. So when we click on Validate Signatures, what we're actually doing here is a quick bit of code that rehashes the document, decrypts the signed hash that's attached to the document with the user's public key and compares the two. So it just gives us some red light, green light indicators showing us whether or not the signature is valid. So that is to say that the signature was successfully decrypted with the user's public key, and that the hash is valid, that the hash that was resulted from that decryption matches the hash that was freshly generated for this particular content. One word of caution, I wouldn't go signing like DVD ISO images, because the bigger it is, the more time it takes to hash, and this doesn't use any kind of an out-of-process or asynchronous hashing. I mean, this does the hash when you ask for the page. I've tested it up to several meg PDFs, and it's quite performant. I think if you were to stick a 5 gig disk image or something in there, that it might get a little angry with you. So again, we can go in with these non-PDF docs, and we can actually validate that this document has been signed by the person it's signed by. So the question came up, what does this look like under the hood, right? You asked about that a minute ago. I'm going to log out as myself and log back in as an admin, so we can take a look at the node browser and see exactly what we're doing under the hood here. Yeah, it's open source, yeah. It's on my GitHub. There's actually the GitHub repo URL is in my last slide. And you can get the slide deck from the Summit website, of course. So we're going to take a look at the node browser and just drop into our workspace here. We'll go into company home, sites, CounterSign, document library, and there's our content. So we'll take a look at like this Word doc, right? So we click on the Word document. We're going to see that there's a few new things that have been added, specifically the CSign signed aspect. So this is how we indicate a piece of content that's been signed, no matter how it's been signed. So PDF, non-PDF, whatever. We always add the CSign signed aspect. That aspect actually points to a signature. So the signature itself is a content type within Alfresco. It's a content node on its own. So if we click on the signature, we'll see some information about this, such as the document hash that it represents. The actual signed hash is in the content stream. It's not in a content property. So this is how we can actually get access to the information about the signatures themselves. They're all stored as document associations that are conveyed by that CSign signed aspect. Backing up a little bit, if we go to take a look at the users, so I'm going to drop down into System, People, and just take a look at myself. We'll see that there's a new aspect added here as well. So CSign signer. When we add the signer aspect to a person, that's basically just telling us that this person has signed documents before. They're actually a legitimate, bona fide signer within CounterSign. That aspect brings us 3 new associations: signature key store, public key, and signature image. So the signature key store, this is the key store where we store all the user's private artifacts. This is password protected by that password that the user provides when they sign. Without that password, they can't access it. We lock the permissions on these down so that only the user themselves and the admin can get to it. So nobody else could go browsing through the repository and find my key store and try to brute force the thing. I mean, they'd have to compromise Alfresco first, then get the key store, and then proceed with whatever it is they wanted to do. The public key is public to anybody, so anybody can download that. That's the public key that you would use to validate the signature. So as long as you were asking about, if somebody forgot their password, you could still use their public key here to validate that they did indeed sign. And then lastly, the signature image. If they've used that little signature pad, to apply a wedding style signature, we persist that image here as well. Now the question has come up previously, well, what happens if I want to reuse those artifacts elsewhere? Somebody might want to download their signature image and use it in DocuSign or another product. That's cool. We provide a really easy way to do that. So down at the bottom, on this page, I'm showing 2 new dashlets that are a part of CounterSign. The first one is My Signed Documents. This just provides a really easy view of any documents that you've signed over a specific time period. So you can go back and say, show me all the documents I've signed in the last 7 days, last 2 weeks, what have you. The second one is My CounterSign Items. So somebody may need to download their key store and add it to Adobe to be trusted, especially if it's a self-signed key store. So if you're not using the trusted key store functionality, you may need to pull down that private or that signature key store yourself. These are just direct links to those artifacts that we just showed through the node browser. So they can pull down their signature key store, their public key, or their signature image for reuse in other applications, which is totally fine. So lastly, actually there is no lastly. That's it. So I want to drop back into my slides real quick. What's the roadmap? Roadmap first, 4.2 compatibility, CAIDS, PAIDS compliance, regulatory targets, refactor out iText and relicense, and enhanced workflow and signing task enhancements. We have a dependency on the iText library. The iText library license is not really cool. So I'm working on reworking the digital signature parts for PDF into Apache PDF box. If that's successful, then I'll be able to refactor out iText and release this under a more friendly license. It's coming. So yeah, that's it for the roadmap. Required reading, if you want to learn more about this stuff, and if you're going to use it and you're at all geeky and you like math, you should really go read this white paper. Bruno Loigi is the guy who wrote iText. He's kind of the authority outside of Adobe on digital signatures. The first couple chapters of this is like a primer on public key cryptography, hashes, signatures, and how they work. And it was absolutely the best thing I ever found to read to get my head around how this stuff actually functions. The last bit, the project and contact info, that's me. You can get the slides off summitalfresco.com. There's the project repository. Right now, it's source only, so you have to download just download the zip file. There's a Maven command to actually build it, so it's just Maven package, I think. But there will be a formal 1.0 beta release with prepackaged amps available probably by the time this conference ends. So that's it. Any questions? Oh. I think I got pretty close to my time here, so we only have a few minutes, but let's get as many as we can.
I noticed in the properties file that when you're going to the beginning of the presentation that an area was grayed out for embedding the PDF, the metadata in the PDF. Is that coming in 4.2?
Which one now?
If you scroll back up a little bit, embed metadata.
Oh, yes.
Says not used or something, right?
Yes. So one of the things that's kind of on my wish list is the ability to also encompass the metadata in the signature, so we can verify that the metadata hasn't changed. I'm still kind of trying to figure out how that's best going to work.
Okay, so that would be in the signature and not in the actual
Right, well, what I want to
itself.
do there is I want to take a snapshot of the metadata from Alfresco, convert it to the XML metadata format that Adobe supports, and then push it into the document header.
Okay.
Along with the signature for it. So that way we can kind of snapshot the Alfresco metadata, embed it in the
like an
PDF,
Adobe custom meta field or something.
Yep, and absolutely compare what's in the Adobe document with what's in the repository to see if they're the same.
Okay. And then the other thing is when you started showing the history of the document signing, is that available as an export, as a file that you could send to somebody to just kind of show, like like a log file or anything of that type, or is it strictly just as a graphic there?
No, part of it is. The validation history for non-PDF documents is absolutely available. There's actually a printable version, which just gives you a little text version of that stuff. Actually, I think that's a dead link right now. Yeah, it is. So the code's there in the latest dev branch. I just haven't rolled it into the last production. That's one of the things I'm holding on before the official 1.0 beta release. However, there's also one of the other features that we're putting in is auditable tags, annotations, on all the relevant methods here. So you'd be able to use Alfresco's audit trail to spit out information about that as well.
Right, because this works a lot nicer than the typical approval workflow, because in an approval workflow, once it's finished, unless you've done customization, all your steps seem to go away.
Right. The workflow history is all there. You just have to know how to query it. So that's what the little timeline does, is it actually goes back and says, well, I'm going to pull some stuff out of workflow history, and it's actually configurable. So if you create your own workflows that use CounterSign, you can tell CounterSign what those workflow IDs are, and it will extract all the tasks from that workflow and display them in the timeline as well.
Do you have a 4.2 target date for?
I'm really hoping by the end of the year, but these guys are running me crazy.
And where do we send the case of beer to thank somebody for creating this?
Pub crawl.
Okay.
I really just a piece of feedback more than a question. First off, I'm very excited about this. It's great, but just knowing my users, the fact that PDF to SWF displays signature not valid, even though it is a valid signature, I guarantee you would confuse the hell out of my my users, and so I'd hope that in some future version that could be fixed.
That's extremely important to me too. I don't ever like having any kind of dissonance between reality and what's shown, right? So I'm working on a different previewer that actually just grabs images out of the PDF, so it does PDF to TIFF. It'll show the signature image, but it won't show any message about its validity.
Even nicer if it could show that it was in fact valid.
That would be great. Unfortunately, that would involve me writing a whole new PDF previewer, which is going to be really hard. So my first target there is to just go ahead and just show the signatures. Second target would be, maybe to do something nasty to PDF to SWF to make it display them. But that's going to be really hard to do. I can't make any kind of prediction as to even if that's possible.
One of our common use cases would be sending a file externally to be signed, and I'm wondering if there's any experience with the cloud offering or other methods of getting that done.
Right. Well, we don't really do extensions in cloud, so that's really as far as the cloud offering is concerned. Right now, there's no way to deploy an extension like this to the cloud environment because it's so many heavy customizations to the repository. One of the things that I've heard some feedback for is the same public signature question. So there may be some ways to create a custom page that uses these same components that might just be not authenticated. So a user could sign in and just do it. Alternately, you could just give them credentials like for your Alfresco repo and let them go in and do so. When we start talking about external signers, things get a little bit complicated. But yeah, that's definitely something I would love to add support for. I just haven't quite gotten my head around what that support means yet.
If you have versioning enabled in the library there, does this create a new version every signature, or how does it affect versioning?
Because it alters the content stream, it would, yes. Oh, one more?
If you drop a document from DocuSign that's been signed, will it activate the aspects and show a signed document?
Almost certainly not. But that's a really good idea, actually, whether or not I could add a type of behavior, for example, that looks for PDF MIME types and tries to figure out if it's signed. I'm going to write that one down, actually, because that's pretty cool. Oh, well, if that's it, thanks, everybody, for coming. This was a lot of fun.